type, but it's area of the entire base times height, not just base times height. So the reason we came up with this formula, the reason we have this formula is it, let's see, I don't have a stack of paper anymore, I used it already. Okay, so if we think about it, you have a shape, you have your prism, let's say this is my base, my hand. If I put another one on top of it, that's another base. If I keep adding another base, and another base, and another base, and another base, I keep adding these bases on top of each other all the way until we get to the top of that height. And that's where we get this volume formula from. It's that area of that base being stacked on top of itself over and over again. Little tiny bases, sort of like little pieces of paper being slid in on top of itself all the way up till it gets to that height. And so that's where we get it from. It's the area of the base times however tall or however many stacks it would take to get your volume to be that height. So it really depends on your unit. So we're supposed to think of these as like infinitely thin pieces of paper almost, or being stacked on top of each other. But depending on what unit you have, it would be like, okay, so this is, you're using 1 foot thick pieces of paper. And so that sort of changes, but you just need to think of it as it's that bottom piece of paper being stacked on how many tall it's going to take. And that height is going to be how many stacks it'll take to get it up to that certain value. Did that sort of clarify your question a little bit, Colton? Okay. So in order to solve this, once again, all we have to find is pretty simple. Area of the base multiplied by the height. So what type of shape do I have for this first one? Rectangular prism. Once again, we're the 3D-dimensional or three-dimensional object, but my base of this is going to be a rectangle, or a rectangle same as a parallelogram. So what is how do we find the area of our rectangle or parallelogram? Or based on type. Well, once again, these are lowercase bases, and so it'll be my base of my rectangle times the base of my height, which if we fill in those values, this is just going to be 3 times my height of my rectangle, which is the distance back of 5, which gives me 15, and then my measurement is feet to feet squared. So that's just the bottom of my rectangle. Are we okay with that so far? And now we're trying to think how many of these stacks of rectangles are going on top of each other to get this 3-dimensional prism. Well, we're getting 3 feet of stacks. So in order to get the volume, it's just that base of my rectangle times the height, how many stacks I have, which is 15 feet squared times 3 feet. I'm actually going to put my measurements on here. So that's going to be 15 feet squared times 3 feet. And so 15 times 3. Yes, Morgan.
Why wouldn't 5 be 0? But are you just doing the front?
So it depends on what you consider the base of your prism. So if you consider this front side to be your base and this to be the height, that can still work. If you were to sort of flip it, that can still be a base. Rectangular prisms are hard to determine really what a base of the prism is because really any side, depending on how it's flipped, could be the base. Because you know that opposite side always going to be the same. So for this, I'm just assuming the bottom and the top are like my bases of my prism. Yeah. But if it were flipped in that way, you could consider that to be your base. So good question. So volume is once again base, area of the base times the height. So my area of the base was 15 feet squared times 3 feet, which gives me 45 feet. And then it's going to be 45 feet to the third, or 45 feet cubed, because it's feet squared times feet gives me feet to the third. So once again, a single foot is just a measurement of length. I'm looking at how long something is. Feet squared measurement is measuring how much space is being taken up on a 2-dimensional, so how much like carpet something is. Feet cubed, or 3-dimensional, that's how much volume entirely, how much space entirely is. So when we're talking about volume, we're going to be using measurements cubed, so centimeters cubed, inches cubed, meters cubed, compared to last week when we were just looking at side lengths. Yes, yes, good question. Are we okay with that so far? So that would be our entire volume of our shape. What type of prism do I have for my second shape? triangular prism. So we have a triangle for our top, a triangle for our bottom. This one is a little confusing because it's flipped to its side compared to be flipped to, or just sort of like leaning on, or having the base on the bottom and having the base on the top. So it's sort of laying on its side and the height is going backwards because, but once again, whatever that defining shape is, so in this case the triangle, that's going to be your base. Once again with rectangles, because all the sides are rectangles, it's hard to determine which side the base is absolutely at the top and bottom, like one said. So if I need to find the volume of this prism, once again, it's volume equals the area of the base times the height. So I need to find the area of that base. How do we find the area of our base of our triangle? Or how do we find the area of a triangle? I'm sorry.
1/2 times
Base equals 1/2 times base of my triangle times height of the triangle. And once again, we always have to recognize what's the difference between my 3-dimensional height of my shape and my 2-dimensional height of a triangle. So if we were to figure this out, the base of my triangle is 4, the height of my triangle is 3. So this is 1/2 times 4 times 3. And once again, these are meters. And so if I were to multiply all that, that's 6 meters squared is just the area of my base of my shape. So our area formula of a triangle is 1/2 base times height. That's just for any type of triangle you encounter, any 2-dimensional triangle. And because we're looking at the area of this, we need to use that area formula. So we use that one. Because if you think about it, a triangle is just half of a square or half of a rectangle cut in half. If you have a rectangle, which is base times height, or in order to get a triangle, you just cut that in half. So it's 1/2 base times height. And that's our triangle. That's where we get the formula from. So we have 6 meters squared for our area of our triangle. Now once again, this is a triangle being stacked, all the way for 7 meters long. So in order to find the entire volume, all we have to do is just multiply by 7. So 6 meters squared times 7 meters. Scroll down a little bit. And that gives us a total of 42 meters cubed. Are we okay with this, where I came up with those numbers, where we pulled everything from? So once again, any prism you encounter, find the area of that base, multiply by the height, and that's your one volume you're done. We're not looking for a lateral surface area and a total surface area together or anything like that. We just need to find the area of the base, multiply by the height. So it's a little bit easier in my opinion than last week. Looking at that second shape, what do you notice? What are some things you're picking up from it? It's a pentagon, so our base is a pentagon. Pentagonal prism, okay. Anything else? Just curious. It has an apothem. We have that measurement from the inside of our shape to the outside, and that'll be important. Okay. How do we, so when we have regular shapes, did we have a formula for those? Not necessarily, based off of like your reference sheet. We had our area of our triangle, area of our parallelogram, and area of our circle was the other one. And so we sort of had to determine, okay, how can we figure out using those areas to figure out what the area of this 3-dimensional or this 2-dimensional regular shape was. And we determined we could cut it into those little triangles and figure out, okay, if I can find the area of this triangle and then multiply by however many triangles I have around the whole shape, that could give me the area of the total. And so we sort of jerry-rigged this formula for the area of our entire shape, which should have been 1/2 times the base of the shape, or the side length, because the side length always represented our bases of our triangle, times the height of your triangle, which was our apothem, because it was from that center point to the outside was each of our triangles, and then times the number of sides. How many triangles did I have in total? That was our sort of formula we made last week to determine our area of the regular contour. So this works for hexagon, pentagon, octagon, whatever you were encountering. Does it seem familiar from last week? Yes, no, maybe so. Yes, okay. And so we can use this once again to figure out what is the area of the base. What is that bottom part? And then once we get that bottom part, multiply by the height, and that'll be our whole goal. So once again, it's 1/2 times my side length. My side length is 6. Get that root. Times my apothem, which once again, the apothem is that center point to the outside, making a right angle, which is 4.13, kind of like a radius. And then n represents our number of sides. So our number of sides, because it's a pentagon, is 5. Are we okay with where I pulled these numbers from? Where each of them, what each of those values represent? What was that called? Okay. So we multiply all this together. You can do it on your calculator, do it on your phone. We should get 61.95 and then inches squared because it's an area. So that should be just the area of our bottoms. And then once again, because it's area of the base times the height, the only last thing we have to do to find the volume is multiply by the height of our prism, which our height of our prism is just 5 inches tall. So it would be 61.95 times 5, and that should give us 400 and something. I forgot to write this down earlier. 61.95 times 5 is 309.75. And then once again, because we're talking about 3-dimensional, it's volume, it's going to be inches cubed. Are we okay with this? Any questions, concerns so far? All right. So that second shape we have there is a cylinder, that second 3-dimensional figure. Looking at your reference sheet, what does it have for the area of a cylinder?
5 times our square.
Or, sorry, yeah, area, volume of the cylinder, I said the wrong thing. But yes, we have pi times r squared times the height, correct? How is that different from our volume of our prism?
You don't have to find that base.
Right, instead of giving us base times height, they give you pi r squared. But looking at a cylinder, what is my base? How would I find an area of a circle?
5 times r squared.
Pi times radius squared. So this piece right here, that is the exact same thing as your base. It's taking that area of the base with the pi r squared, and then it's multiplying it by the height. So it's still that same method we've been using, but rather than sort of splitting up into 2 steps like what we were doing over here, they just combine it into one big step, doing pi r squared times h. So rather than making 2 formulas, they just sort of shortened it into one. Does that make sense where we can pull that from? And that's the reason they can do this is because a cylinder is going to have the same base every time. You're not going to get a cylinder that's, I don't know, has edges on it because it's a cylinder. It's supposed to be circular. Well, compared to a prism, we can't necessarily, our prism might change because we might have a square base, we might have a rectangular base, we might have a pentagonal base. And so that's why with prisms we have to have that capital B, but with a cylinder we can actually just put what the actual formula would be. Are we okay with that? All right. So if I were to fill this out, what would I have to do? Someone sort of walk me through what they would do.
5 times 4 squared times
Times our radius, which we're told is 4, awesome. Times our height, which we're told is 8. Simple, easy, plug it in the formula, plug it in your calculator, we should be good. So pi times 4 squared times 8. Wrong button. Times 8. And that gives us 402.12, and then once again, centimeters cubed, because we're talking about area. The cylinders are really easy. Find that radius, find that height, plugging in the formula, you have your volume. Feel comfortable on that? See if you can do this last one on your own. I'm going to leave this one up here just so you have an example. See if you can get that last one on your own, and then we're going to talk about some situations that, or we'll look at an example of when we could use this. Don't worry, Stephen. The screen just so. All right. So someone walk me through this problem. What did they do? What were sort of the problems? Alex?
I chop my diameter in half first, so 4.5 is their radius.
Okay, good. So they give us the diameter, so we need to recognize when to get the radius from the diameter. Awesome.
Yes. And so yeah, just plug that into where our radius goes to our, pi, pi r squared times height, and then my height is 12.
Okay, so you had pi times 4.5 squared times 12.
Yes.
Okay, and what did that turn out to be?
763.4.
763.4. Ooh, my pen's doing that weird thing again. So 763.4. Okay, 0.4 feet. And then because we're talking about volume, we'll want to make sure it's feet cubed. Yeah, 763.4, I think. Good, good. Any questions on any of the steps? Did anyone get anything different or worry about that? Awesome, cool. So we're going to look at a problem that we can use volume to help us solve. So we're going to look at a situation, we're going to watch a video, and then try to make some assumptions about it and try to make some guesses and use this volume formula to help us figure out what's actually going on. So my video. All right, so this person says, as a kid, my sister would split one soda between two glasses, and then I would pick which one I wanted. So the sister would pour the two glasses, and then he would pick, or she, sorry, it doesn't really choose which one. And then they would say which glasses they wanted based off of how much soda they thought was in each glass. So this person cracked open a soda and filled it between two different glasses. And we want to determine which glass do you think has more soda in it? Is it going to be our tall, skinnier glass, or is it going to be our shorter, stouter glass? You think it's going to be the same? All right. That's fair judgment as well. So if you flip over your paper, it should say official guess on it. I want you to write down which guess do you think is, or which glass would you pick, or if you think it's the same, put that down. So what we're doing is, we talk about that problem, and then we're trying to guess which of these two glasses do you think has more soda? Based off of this, this kind of soda split between two glasses. Which one do you think? Okay, so it's not the same as the left. So you think they're pretty close, but the left might just have a little bit more potentially. Higher glass.
Yeah, I think they're really close. Like the balance is maybe a little more useful.
Okay. What about that today? The right one? Okay. So, seems like the majority of people are going towards this right one. Colton, you said even, but maybe the left one? Okay. Yeah. So a little bit split. Cool. So let's see if we can figure this out. Wrong button. What pieces of information could we think of that can help us solve this? There's the glasses. Now, if I took those two glasses and I measured their height, is that going to tell me anything about how much? We're going to need the height of the liquid. So Yeah. Or height of the soda. So because if we measure those glasses and just find the volume of the total glass, it doesn't actually tell us how much volume is in the entire glass or how much liquid is in the entire glass, just how much it can hold. So good. We'll want the height of the liquid. Any other thoughts? We're going to need to find the base in order to find the volume. What are some pieces of information we need to know for the base? We're going to need to know the radius because the base area of a circle is pi r squared. So we'll have to figure out what that radius is. So let me ask you this. If I give you a cup, for the radius we need that direct center. It's from the center to the outside. If I give you a cup, could you find the direct center of that cup for me on the bottom of it?
Usually there is. Sometimes there can be market centers.
Sometimes. But if you just had like
a guess, just like.
But if we want to be more accurate, I spelled radius on. Would it be harder to find the radius though? Would you know you found the direct center of that cup just randomly looking at it? Why don't you just get a ruler? So what do you mean get a ruler?
That's genius.
Just get a ruler.
The length of the bottom. So you're applying for the base and then like finding the exact center of that specific length. Midpoint.
So rather than looking for the radius of the glass, because finding that point is hard, we can look at the length across the entire glass, or across the entire circle, and find that longest length, and that can give us our diameter, which is a little bit easier to measure. Good thought. So diameter is a little bit better to measure compared to the radius, just because we can find the longest length compared to finding the radius, or compared to finding that center. Any other thoughts on what we might need in order to solve this? So let's say I gave you these measurements. Let's say I gave you the diameter and the height in centimeters. What would your answer come out as? Centimeters cubed. How much liquid goes in a centimeter cubed? Is that a measurement of liquid though? Let's convert this, and we'll convert it to ounces. Because that will actually give us an amount of liquid compared to just an amount of space. And that might be a little bit easier to compare number space off. So these are the three things we need. We need the height of the liquid, the diameter, and then our centimeters cubed to ounces. So we have our measurements. We have the height of our taller glass is 10 centimeters for the soda. We have the diameter of that glass to be 5.5 centimeters. The height of the soda for the shorter glass is 3, and then diameter of that one is 7. Thinking the left one now that you know the measurements? Okay. Take a moment, write those down, and then we'll look at what the conversion is from centimeters cubed to ounces. Okay, so our conversion between these two is from going from 1 cubic centimeter to US fluid ounces. It's 0.03381. So we're going to round that. That's a lot. So we're going to round that to roughly 0.034. So if you get an answer in centimeters cubed, in order to figure out how many fluid ounces, we have to multiply by 0.034. So we'll multiply by this, and that'll give us our actual answer in fluid ounces. I think that's the thing for fluid ounces. So now that we have all this information, see if you can solve this problem using those volume formulas that we just talked about. Using the volume of the cylinder, see if we can find which glass actually has the more liquid.
What if they ring?
All right. What did we find for our two volumes?
For the tall glass,
8.07 fluid ounces. Once again, we have that 5.5. We cut it in half to get our 2.75 squared times 5 times 10. Multiplied by your conversion, we got, what did we find for our short glass? 3.94, 3.93, something like that, fluid ounces. So these were our two amounts. So it actually seems like the tall glass was almost twice the short glass, even though it doesn't necessarily look here. So let's check just to make sure this is right. Let me freeze this really quick. I'll pull up this other video. Okay. We have our two glasses, pour them into measuring cups, and we have 8 ounces to 4 ounces, which is pretty much rounded, of course, what we have, but good. So we were able to use our volume to figure it out. Awesome. So tomorrow we're going to talk about pyramids and cones and spheres. We're going to look at those other three formulas we have. And then Wednesday we will do composite shapes. So what happens if you have two shapes that are sort of put together, like a sphere on top of a cone, or if you have like a box with a cylinder on top. We'll look at how do we find those areas going to the composite shapes. And then on Thursday we'll do some practice. And Friday I will not be here. On Friday I have a meeting for that thing. And so I won't be here on Friday, but you'll still have a sub. So we'll still be taking the assessment, but you'll have time to like study and practice before the assessment. And then you'll be able to take it. I just won't be here to actually take it before. Is that okay?
We don't get so.
I don't know yet. I don't typically figure out until like the day before, if at all. Mr. Rapp is a good sub.
Well,
I like Mr. Rapp too. He's a really good sub. All right, so good job.